Looks like here we've got some math being applied to construction. So the farmer needs two identical rectangular enclosures. So what I could do is start by just making a rectangle. And then if you cut that right down the middle, you've got two identical rectangles. And they share a common side. So that is the common side they're sharing. Okay. So that's that part. And then, since it's a rectangle, well, it says to use x as the width. So that means this would be x, this would also be x, and this would also be x. And then for the bottom and the top, I can't use x because that would make it a square. So just use a different letter like y. So the bottom is a length of y and the top is a length of y. And then the next thing is, it says there's 120 feet of fencing total. So that's also sometimes called 120 linear feet of fencing, which means we don't know how tall the fence is, but if you roll out that material, it's going to measure a length of 120 feet. And then, just in case you ever hear this, in construction, they call it lineal feet instead of linear. In math, we call it linear. Same thing. Okay, so that means that if you add the 5 sides, then that has to equal 120. So if you add those, that means we've got 3 x's plus 2 y's, and that equals 120 feet. So we're up to right here. Find a function for the area. Well, area just means multiply one side with the other, so the area is equal to x times y. And then find the maximum. So that must mean that we've got some kind of parabola situation, and then we could find the maximum. But a parabola has x squared, and so far we don't have x squared, but it's going to show up. Because what I could do is, in this equation, I could solve for y. Whatever I get, I plug it into that equation for the y, and then we're going to get a quadratic or a parabola. So I need to solve for y. Subtract 3x from both sides. So then we would have 2y equals a 120 minus 3x. And the next thing to do to solve for y is divide all of the terms by 2. So we would get cancels. So now y equals 120 divided by 2, that's 60. And then 3 divided by 2 can't be reduced, so just leave it like that. And then, like I said, we're going to take that and plug it in for that y right there. So then the formula for the area is x times y, but then replace y with 60 minus 3 over 2x. And if you multiply this out, then you'll see that we're going to get an x squared, which means it's a parabola. So when you distribute the x to the negative 3x, that's the x squared part, so I'm going to do that first. So it gives us negative 3 halves x squared, and then plus the x times 60, or 60x. And then that, sure enough, is a parabola, and because of the negative in front, it's an upside down parabola. So then you could find out the max by just using the formula negative b divided by 2a. So this is the a, this is the b. And so for the maximum, x will need to equal negative b, so that's negative 60, divided by 2, and then the a, which is negative 3 over 2. And it looks like I could do this even without a calculator, because the 2 on the top and the 2 on the bottom will cancel. The negative will cancel the negative, and all that's left is 60 divided by 3. That is also known as 20 feet. And we're almost done. It did say find the dimensions, so that means we need to find the x and the y. So go back to this equation up here where we have y now circled in red, and then go, so that means that y equals 60 minus 3/2 times x, and we just got a 20 for x. And then just simplify, a 2 will divide into 20 10 times, which means that y is 60 minus 30, also known as 30. So that turned out very nice, 20 by 30. So basically the dimensions then are 20 feet by 30 feet.